sheet on the test on Thursday. Again, I don't know for sure there was an incident in here, so I'm not even going to accuse. I'm just going to let it go, and you can have whatever stink grade you make. If you did cheat on Thursday, though, because you've not been paying attention and you don't know what's going on, it's only going to get worse, because sadly, we have the final test for Chapter 5 coming up. And on this final test, we've got to use the stuff from the first test and the middle test to help us figure out this last test. So if Daylin phoned it in on the second test, which she didn't, but if Daylin phoned it in on the second test and copied Abby Grace, I don't know what she's going to do about the third, because the third is, again, building on the second. Okay. Let's go over these math workshops, and then we'll get started on our notes today. I know this sounds crazy, but the final Chapter 5 test, because we've not got much left, is on Friday. Okay, number 1, what can I factor out? More higher than that? Yes. So what am I left with? You can have your point, Travis. Okay, on number 2, there are how many terms? So I'm supposed to... Okay, and if I grouped, what should I factor out? The first group? What am I left with? And what should I factor out the second group? And what am I left with? Okay, I'm going to give 2 and 4 point. So my final answer is 3D minus 5, T minus 7. Again, we're still practicing factoring, because guess what? We still need factoring on this last test. Number 3, I need 2 things that add to negative 8 and multiply to positive 64. So we would call that 3, you can have a point. I mean, we could have thought through 164, 232, 8 and 8, 4 and 16. There are lots of options, but none of them have a difference of 8, so it's not factorable. More specifically, though, can you tell me what that means about the solutions to that graph? Yes, they're too imaginary. I heard Jessica. Brady, did you say it too? Okay, well, we'll give Jessica a point. How could I confirm that those actually are 2 imaginary solutions? 5, get the point. I've typed in number 3, x squared minus x plus 64. I press graph, and it's done, and nothing shows up on the screen. What does that mean? It's so high, it's not even crossing my x-axis. It has to cross the x-axis in order to be an actual 0, so it doesn't have any real zeros, so that's why it's too imaginary. Now, if you're insisting on seeing it, you can change the zoom to zoom fit, but I don't recommend that, because zoom fit, it makes it look as if it crosses the x-axis when it really doesn't. We're questioning whether or not something crosses the x-axis. It's best to be in zoom standard. Your normal 10 by 10. Zoom standard 5, 6. Oh, I pressed square. That's why. Zoom standard, because it's your normal 10 by 10. But again, it's not showing up because it's so high, it doesn't even fit on our 10 by 10, which is fine. Hello, dear. Okay, so let's go to number 4. It's my favorite. Why is that? It's what? Cubes. They're both perfect squares. Brady probably got out the words. Perfect squares. I don't either. And then so it's supposed to be what? And what's the other one? 3 point. He was so close. You can have a 0.5. Thank you, 3, for being so honest. No. Brady doesn't need pity points. Okay, which leads me back to your test that I guess I'm going to forever stick on today. how come you recognize that was the difference of perfect squares and you solved it by factoring, and on the test when it's the difference of perfect cubes, some people didn't factor? I had at least, I'll tell Allison, I'm sorry later. Allison did. She factored. I'm not saying she's right or wrong, but she factored. But I had some people who didn't factor on number 8. They did not use SOAP. They did not use the difference of perfect cubes. Instead, they just said that was equal to 0. So 8x to the third equals 27. So x to the third equals 27 over 8. They took the cube root and got x equal to 3 over 2. I don't know why they did that. I mean, I understand their logic, but that's not what we've been doing during class. We've been factoring. Why did we not factor? If that's you, then you want to come see me later because you want to fix that. Otherwise, I'm going to count off, I think it's 4 points that I take off for that. Okay, so if we're done with the math workshop, let's go to our notes. Caitlin got her group point for asking a good question. We've already discussed the weirdo factoring you had to do on the last test and the fact that you've not shown me those 18. Caitlin got a point because she asked me when she's supposed to show me those two. I'm going to let it go and be like Elsa. I'm already mad enough about DJ about the maze. I got to let go of something. Got to let go of something. Now, the whole point of Friday's synthetic substitution was it might take Drea a while if she actually plugs in 4 everywhere she sees an x in a function. It might take her a while to calculate that. It's actually faster to use synthetic division, and whatever the remainder is what the value would be if you had actually plugged in a 4 everywhere you saw an x. Now, on some problems that might not be time saving, like on number 8 it certainly would be because there's so many pieces. So if you were not loving evaluating a function, then an easier way to do it is with synthetic substitution. Now that leads to the bottom of the notes, which we're actually going to skip. I'm just going to talk about them now. So the bottom is cheating. They tell you, hey, this is one of our factors. Can you find the others? We're too cool for that now. We're about to live in a world of I don't know any of the zeros or the factors. I need to figure them all out. So why even go there where there's 1 given? No, forget it. Let's go straight to I don't know any of them. Let me figure it out. Okay, so if you were in pre-AP Algebra 2 with trig, they would stress over the formula on the next page. Let's look at it and talk about why Ms. Compton does not stress over it. Okay, so there's this theorem called the rational zero theorem. And while it's terrific and great and everything, I think it's a pain in the rear, so I rarely ever use it. Okay, so let me tell you what it says. So if we look down at the bottom one, I'll tell you it in about a minute. It doesn't even take that long. Tell me all the things that multiply to 24. Okay, 6, 4, 8, 3, 2, and 12, and then 24. Okay. Now, I could put that in a better order. I could do 1, 2, 3, 4, 6, 8, 12, 24. I get that's not in numerical order. But those are all the things that multiply to 24, right? So we look at the number on the end. We figure out all the stuff that multiplies to 24. We also look at the number in front of our leading coefficient, which is a 1. What are all the things that multiply to 1? Yeah, just plus or minus 1. We actually call this one the P. We call that one the Q. And all our potential zeros are P over Q. So meaning, if Abby Grace is trying to figure out exactly where this graph crosses the x-axis, she's got some good guesses here. She could guess 1 over 1, 1 over 6, 1 over 4, 1 over 8. But heck, she could also guess negative 1 over 1, negative 1 over 6, negative 1 over 4, negative 1 over 8. So while this theorem is great because it does give us a list of options, my gosh, there are so many options on this list. Who wants to go through them all? Not me. So we're not going to. So there's this theorem that tells you, like, hey, try all these things, but Drea is like me. We're in a hurry. We're not going to try them all. That will take all day. Let's move on from that. So instead of doing that, we're going to cheat, and we're going to use a graph calculator. Go to the next page. off the sonograph calculator. Did you get one like you were supposed to? You get it back now from here on. I had a promise to you the other day. What did I promise you? No problems that were what? And 2 gets the point. They can't be degree 5 or higher. Guess what? It's out the window now. Got the calculator back. We can go to pads remote. Okay, so let's type in number 1. X to the 3rd plus x squared. Clear, clear, clear. Hopefully you type that in faster than me, my goodness. X to the 3rd plus x squared minus 17x plus 15. I press graph. I get this. And hey, suddenly what I did last week makes sense. Because, you know, I don't know how you're ever going to pass the one on Friday if you own your phone. I just don't know. Finally, the one from last week makes sense. It was a cube. It was supposed to be a snake going up the wall. Hey, I see a snake. He kind of goes off screen, but he is definitely going up the wall. So I know I'm correct. If you had to guess where the zeros were, what would you guess? Positive 1, 3. Yeah. So we'll give it to 4. No. We'll give it, 1, 4, and 5. We'll give 5 2 points because she came up with 2 of them. Okay, so, and that's great. And for once, that is actually the correct answer. So if you want to go ahead and list it, I know for sure it is -5, 1, and 3. Which is great. We found all the zeros. Let's talk about how to check that. Okay, so how do I know for sure that is actually at 1? Yeah, so I normally would say second calculate and then zeros, but that's a little too complicated, so that's why Landon's going to get a point. You could look at the table, but the easiest way to actually do it is to press trace. And so if you press trace, and then you can guess your answers. So like you thought 1 was an answer, so press 1 and then enter. Hey, at 1 we actually get 0. 1 is an answer. You thought 3 was an answer. Let's check it out. So I press trace, then 3, and then enter. Hey, you're right. 3 is an answer because at 3 we have a y value of 0. And last but not least, you thought -5 was an answer. So we plug in -5. Make sure you use the correct negative symbol. Hey, it really is there. You could do that, yes. We're only going to need to do the second button if it's a decimal one. So thankfully, since these are all whole numbers, Trace is going to save today. That's a great question for you. You can have another point. Okay. This is great, and we have the complete set of answers for number 1. So what I'm about to do is kind of done. But I'm going to do it because we're going to do it on every other problem because every other problem is not this nice. So we should at least practice to make sure we got our life right. Okay, so let's pretend. We know 1's one of the zeros, right? So why not use 1 in synthetic division and figure out the remainder? So I would have a 1, a -17, and a 15. Because I know 1's one of the answers. I bring down my 1. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. -15 times 1 is -15. And I get a remainder of 0. Any problem we're doing on this next test, you ought to get a remainder of 0, or else that number is really not a factor. So yes, we did it correctly. We were supposed to get a 0. Okay, so it was a cubed, so my new polynomial is at 1 degree less, so x squared plus 2x minus 15. Now, I'm being real crazy now, I know. I know we already know the answer is 1. But do I put x plus 1 here or x minus 1 here? It's the opposite sign, so it's going to be minus. Yeah, because minus 1 would lead to that positive 1 answer. This one led me to here. Okay, and then again, we're cheating. I know, but I like cheating. Well, it's not cheating. We're using our graphic calculator. Is that really cheating? No. So we need to know how to factor that. And we know 5 and 3 gives you 15. I already know it needs to be a positive 5 because my answer is a negative 5. I already knew it needs to be a negative 3 because my answer is a positive 3. 5 minus 3 is positive 2. 5 times negative 3 is negative 15. But again, I knew how to factor it because I already knew what the answer. Okay, and then Derek was looking at me like, well, if we already knew all the answers, why on earth are we doing any of this? And I agree. So in real life, if I had a problem like number 1, I knew my 3 answers, I'm done. Sadly, every other problem on this paper is going to require a little more work than that. So that's why we went ahead and practiced the extra work. Let's go to 3 because number 2 is super long and oh. Okay, so in number 3, let's graph it. I know it's a fifth, so it's some sort of a snake. So x to the 5th minus 8x to the 3rd minus 9x, and I graph it. Okay, so where do I guess my zeros are now? 0, where else? Okay, perfect. And that was 1 and 5. So let's check them. So I press trace. Let's guess, is 0 really 1? Yep. Trace, is 3 really 1? Yep, because I got 0. Trace, is negative 3 really 1? Yep, because I got 0. So terrific. You already figured out it's negative 3. I could put plus or minus 3. Do what here? The dotted line. When you press trace, it lights up like that. It wants to know where you're tracing to. It's part of the trace function. I didn't make the calculator, Travis. Oh, yeah, it is weird. If you have a colored one, it shows up in a different color. Okay, so we got negative 3, 0, and 3. Okay. You're very smart. Why is that list incomplete? How many answers am I supposed to have on this problem? I'm supposed to have 5. Why am I supposed to have 5? Because it's a degree of 5. So 2 figured it out first. We'll give her the point. My degree was 5. I should have 5 things listed here. I only have 1, 2, 3. You can see why on this problem, Derek is going to have to do a little something extra because she needs a list of 5 and she's only got a list of 3. Now we could go straight to using synthetic division like we did on number 1. But number 3, there's actually something we could factor out first. What could we factor out first? Yes, 5, get a point. If we factor out an x, we would have x to the 4th minus 8x squared minus 9. Again, if Derica wants to go straight to synthetic division, I'm not going to know. Ms. Compton is, of course, a math teacher, so she's going this way on purpose because we just tested on problems like that. What am I supposed to do if I've got a quartic and I need to know how to factor it? 2 gets the point. So it's supposed to be y squared minus 8y minus 9. How do we factor that? What adds to negative 9 and multiplies, no, adds to negative 8 and multiplies to negative 9? Okay, does everyone understand how we went from this green to this pink? What do I need to do now? We got to go back to x's. So I'm going to bring down that original green x, and I'm going to change that to x squared minus 9, x squared plus 1, and then yay, we can finally for real figure out our zeros. Okay, so Mason's got this. He sees how if this was equal to 0, He knows x equals 0. That's how he got that 0. He knows x squared minus 9. He probably did x squared minus 9 equals 0. X squared equals 9. X equals plus or minus 3. He sees how he got the positive 3 and the negative 3. So he's dealt with this one. He's dealt with this one. He's got to deal with that x squared plus 1. So I'm just going to put what? So I've got x squared plus 1 equals 0. And what I end up getting is my two answers from there. Yes, I do get imaginary numbers, and she keeps saying 1i. Can someone just fix it? Okay. So I got x squared equals negative 1, and then Ivy Grace took the square root, so she had x equals plus or minus the square root of negative 1, which is just plus or minus I. So finally, Mason understood where he got the negative 3, the 0, and the 3. He got 3 of his 5 answers, and then plus or minus I are his other 2 answers. I'm not going to know if Derica doesn't even do this. If she just uses synthetic over and over and over again until she gets that bad boy all the way factored down, that's fine too. I'm not going to know whether or not she hates this factoring or not. I don't know. Okay. Are there any questions on that one? Let's back up and do one more, and then I'll stop rambling about this today. We'll do a ton more tomorrow, I'm promising you. That's our next 3 days. That's what our next test is this. Let's go to number 2. Go ahead and graph number 2 while Kenzie asks me a question. You're doing means, and they're telling you, because it said x bar, so that's how I know it's a mean, because it said mean. And then they're just saying it normally is 11.9, well they have to be less than 11.9. So z table still. Okay, go on. Why is this one annoying? Okay, and you get a point, but also, why else is this one annoying? Well, yeah, those big numbers are annoying. That is for sure darn true. But still on the graph. So Landon said it's annoying because it only crosses once. If only he could add some more words to that. Say what now? Okay. Jessica gets the point. Let's talk about this. So I graphed it. Did everyone else get this? Yes. The ugliest thing you've ever seen. Wasn't it supposed to be a W? Can I show you how I got it? Yeah. I typed in x to the 4th plus 6x to the 3rd plus 73x squared plus 384x plus 576. If you typed it in and it didn't look right, press zoom and make sure you're on Zoom standard. Okay, so I got this weirdo thing. What was I supposed to get on this problem? You've been graphing for weeks now, I feel like. Number 2 was an x to the 4th with a positive leading coefficient. What did you expect to see? A W. Did we see a W? No. But Jessica's already saved the day. At -3, what happens? It has a multiplicity of 2 at least because it bounced. So I already know for sure. So let's go to number 2. I was supposed to have 4 answers, right? But I already know the answer -3 has a multiplicity of 2. So if I listed it, I would list that bad boy out twice. I actually only need 2 other numbers because 2 of them are -3. Now, is life that deep? Does Derica have to remember all that? No. But it sure does help her not freak out at the end of the day that she's got -3 on her list twice. She was supposed to have -3 on her list twice that had a multiplicity of 2. Okay, so bless our hearts. All we know is -3. We're going to have to use synthetic. So 1, 6, 73, 384, 576. I bring down my 1. I get positive 3. No, we thought negative. No. No. It's because it's. The 0 is negative 3. Okay. 3 times negative 3 is negative 9. 73 minus 9 is 64. You can have a point for that. 64 times negative 3. Thank you. 384 minus 192. Positive 192. 192 times negative 3. Negative 576. Again, DJ knows he's completely correct because he was supposed to get a 0. So this problem is super annoying because it started off to the 4th. Heck, we're only at x to the 3rd plus 3x squared plus 64x plus 192. So it's not like life got easier. You just took a test. There are 4 terms. What are we supposed to do from here? We don't have to do SOAP because we can do grouping because there are 4 of them. Let's group. Okay, I'll stop rambling. Sorry. We'll come back to this one tomorrow. Bless you, Caitlin. If your group's not at a 5,